So that's a lot of data collection use cases. Next one is not related to data collection, but more to optimization. And especially when you want to run optimization processes close to the data sources. And this use case is for optimizing the operation of some kind of machine or process or whatever that might sit on in the production environment. So here we first get data from the machines, in this case using Modbus as an example, but it could of course be any type of industrial connector on the input side. So we get the number of data sources or tags from the machines. And we do this repetitively, so we get a stream of data coming out of this input module. Then we typically need to do some kind of pre-processing of this data, here exemplified by converting these streams of data into sliding windows, which are then fed into a machine learning model, which is running inside our Python module. So this Python module gives you access to a full standard Python environment where you can also install any third-party libraries. So in this case, that is used to install the relevant machine learning framework that is needed to execute the trained machine learning model. And then we feed it with data that we have collected from the machines, and the output of the model is some kind of optimized settings that we want to feed back into the machine. So we use on the output a Modbus module again to write data back to the machine. But again, this could be any of the machine connectors that we offer. So this, if it's discrete manufacturing, this could be used for optimizing the yield of the products being produced. If it's process industry, it could be used to optimize the energy consumption or the use of consumables like chemicals, for example. So this is a quite common scenario that we start to see a lot since the last year or two. So this is used in many places today. And the advantage here is that since you can deploy these flows anywhere, you can run these use cases very close to these machines or process lines that you use. And that means that both the data stays in this local environment. You don't have to expose any of this data outside this local environment. And for some use cases, especially in discrete manufacturing, you could also benefit from getting very low latency, since data, it's a very tight closed loop where data stays in this local environment. So you can run this also with low latency.